Hi, everyone, and welcome. Thank you for joining us today, whether you're here in person or tuning in on the live stream. Yesterday, during the keynote, we announced Interactive Canvas, a new set of tools that allow developers to create visual content for the Google Assistant. Today, we want to talk to you about how you can use this technology to build interactive games for the Google Assistant. First, a quick introduction, though. I'm John Hsu. I'm the product manager for Interactive Canvas and for games on Google Assistant. And I'm joined by Nicholls, who's on our developer relations team. The past 10 years, I've had the pleasure of building games for new platforms, from web games to social games to mobile games to voice games. What I'm excited about whenever a new technology comes out is the fact that a transformative type of experience starts to emerge for the player. And in addition to that, a transformative type of experience allows new developers to enter the marketplace and create these experiences. What we believe the Google Assistant and Interactive Canvas unlocks together is a new way and a new potential for players to engage with our games. I'm excited for everyone here to start building visual games on Google Assistant. First, let's talk a little bit about games on the Assistant today. The past 2 years, we've seen good traction on voice games built for Assistant. Developers have crafted great interactive experiences like Akinator and Trivia Crack that really take advantage of what Google Assistant is meant to do, understand what the user is saying. These games have been successful at creating immersive experiences with only audio as the output. Last year, when we announced smart displays, we were starting to see increased engagement from players that on these display devices. Over the course of 2019, the percentage of smart homes that now include a smart display device has quadrupled from less than 3% to over 13%. Canvas is the tool that will unlock these visual capabilities in conjunction with Google's NLU, natural language understanding, and speech recognition. Canvas essentially gives you full access to the display. You can create fluid animations and custom game experiences with technology that you're already familiar with: HTML, CSS, JavaScript, and even WebAssembly. Pairing these visual capabilities with our speech recognition allows you to create transformative experiences. This technology is available on Android devices and our smart displays, with more surfaces coming soon. Let's take a quick look at the examples and see what's possible. HQ University, as you saw in the keynote yesterday, leverages HTML animations to create a high-quality experience for the user. In addition to just having animations, we have the capability to leverage those animations to create moments of user payoff when they get the answer correct. Lucky Trivia, also known as Are You Feeling Lucky, uses a similar technique to provide payoff, but also uses the visual surface to simplify multiplayer experiences. When you only have audio output, it's often very difficult to keep track in a trivia game of whose turn it is, who made what answer, enough so that Lucky Trivia team actually, in the voice-only experience, changed the interaction model so that you actually sequentially ask questions to different players. With a visual surface, though, Lucky Trivia can take advantage of the visual display to effortlessly show who's making the answer, and more importantly, who got the answer right. Finally, in our sandbox in Sandbox H, we are displaying a new interactive game called Jungle Dream, where we are leveraging visual puzzles that can't be done on audio devices. By allowing the visual surface to be integrated with your core mechanic, we are allowing developers to create awesome new experiences that really utilize this visual surface. But that's just the beginning. By the end of the session, you'll be equipped to create even better experiences than what we've just shown. Here's how we get started.
So let's look at the technical details. So Interactive Canvas uses regular HTML. That means CSS, JavaScript, SVG, even WebAssembly. WebGL has been optimized for 2D and 3D graphics, but you can also just use the standard HTML Canvas feature to do some basic graphics. You can use the standard HTML media element to play audio or video within the local web app. We also support the standard touch events for both smart displays and for mobile devices. Now, Interactive Canvas gives you pixel-level control over the rendering of your UI. So that means custom layouts, use your own fonts, add transitions, add animations, create a custom GUI, create your own custom buttons, tables, lists, whatever. All of this is now possible. So what is an interactive action? Well, it's a conversational action. And just like you create a conversational action in the Actions console, you do the same with an interactive action. Also, you use our existing tools like Dialogflow or the Actions SDK. Now, we definitely recommend using Dialogflow. It has a very nice GUI for you to easily create intents, and it has built-in natural language understanding. You also write code, which is the fulfillment that provides dynamic responses for your intents. And now you provide a new kind of response, an immersive response. If you've done a conversational action before, you already know about simple responses and rich responses. This is something similar. So let's go through all of those in steps. How do we start creating an interactive action? Now, we're launching Interactive Canvas for games initially. So in our Actions console at console.actions.google.com, you select the games vertical to begin. Next, you get a list of options for creating different kinds of games on our platform. The first three are based on templates, but we're going to pick the last one, which is for a conversational action. Next, in the directory listing for your project, you have to ensure that the category is games and fun. And there's a new checkbox right at the bottom of the screen for the Canvas feature. You have to check that and then save it. Now your project is capable of using the new feature. Next, we add the action. So we go to the Actions page. You click on that big blue button. And now we display a dialog with a list of built-in intents. Now, built-in intents is a way for your action to tell the Google Assistant what kind of action it is, and also what kind of user requests it can handle. Now, since we're creating a game, we're going to pick the play game built-in intent. After you've clicked on that, the Dialogflow GUI is loaded, and you get 3 intents. The first one is for the play game built-in intent. The second one is the default fallback intent. That's what Dialogflow invokes when none of the other intents are matched. And then thirdly, there's a default welcome intent. Now, that gets invoked when the user invokes your action by name. So the user would say, OK, G, talk to conversational action. Let's take a look at the play game intent. Now, in Dialogflow, it's actually a play game event. And you can associate that event with any other intent. For example, you could associate that with the welcome intent and reuse that intent for the various different ways that the user can actually start your action. Dialogflow also has a very convenient inline editor. So right within its GUI, you can go and write Node.js code for the cloud functions for Firebase. Every Dialogflow agent actually gets a cloud function for free. And now we're going to base all of our examples on the cloud functions syntax. OK, let's start at the beginning. Let's look at what a conversational action is implemented in Dialogflow. We start with the user. The user talks to a device with a screen. That information is passed on to the Actions on Google platform. Actions on Google realizes, oh, this particular action is implemented in Dialogflow, and forwards it to Dialogflow. Dialogflow takes the user input, matches that to an intent, and then invokes the associated fulfillment, the code behind that, to provide a dynamic response. And for screens, you could provide something like a rich response. It could be a list, a table. These are all existing widgets. That rich response is forwarded to the device, and it's displayed to the user. So that's how conversational actions work today. So what is an interactive action, also implemented in Dialogflow? Well, you notice our diagram is very similar, but we have this new component. So again, let's look at the life cycle. The user talks to the device. That user input is passed on to Action on Google. Action on Google invokes Dialogflow. Dialogflow matches the intent based on that user phrase. It then invokes the associated fulfillment logic, and it provides a response. But now it provides a new kind of response. an immersive response. So it's similar to simple and rich, but it has some extra data in there. As part of the immersive response, you provide a URL. That URL is forwarded to the device. The device loads the associated web app from that URL. When the web app starts on the device, it initializes the interactive Canvas API. It also registers some callbacks. Now, this is the way to pass in information to the web app, and there's also a way for the web app to communicate back to Actions on Google. So if you look at this diagram, it's very similar to an existing lifecycle of a conversational action. We just now have this new way of visualizing the action on this device with a screen. But let's look at the code, both for the fulfillment, for the intents, and also for the web app logic for your game. Now, the intent fulfillment needs to provide an immersive response, right? Actions of Google through Dialogflow matches the intent. The intent says there's some code, invoke that code. That code generates an immersive response. Our Node.js client library has been extended with a new class, literally called immersive response. Very simple, like simple and rich response. There's also a new surface capability. So in your fulfillment code, you can go and check, is the device that the user is talking to capable of doing a Canvas experience? If it is, you can use immersive response. If it isn't, use our existing responses like simple and rich responses. As part of the immersive response, you need to provide a URL. It needs to be an HTTPS endpoint. That gets forwarded to the device loads the web app. Let's look at the fulfillment logic. So this is our Cloud Function code. We're using our Node.js client library. And here we have an intent handler for the default welcome intent. Note we're using an instance of the immersive response class. And there's two pieces of information you need to pass. Firstly, the URL. That's the HTTPS endpoint of your web app. Secondly, some state information. Now, here we have a variable that's initialized to the value welcome. But that state object is actually a JSON object. So you can pass in any JSON payload from fulfillment to your web app. But for our examples, we're going to keep it simple with simple states. And that's quite a common thing for games, to track states from fulfillment and pass it on to the web app. So the web app, it's regular HTML. You have to write some JavaScript code. There's a few things you need to do. Firstly, you declare these event callbacks. Second, you need to listenize the library we provide for Canvas. And as part of that, you actually register those callbacks with the library, and then it's ready to accept events. And then within your event handler, you'll have some custom logic that as the events are coming in, you'll match that with the game state within your game. Now, if you're a web developer, you're probably relying on some popular framework or library. Those will just work as is. So if you're using Pixie or Tween.js or React, those will work just fine out of the box. However, we do recommend you use a single-page application. And this is important because you can reuse the web app across intent invocations. It also ensures a seamless UX experience for the user. Now, we recommend using Firebase hosting for getting started. It's actually a super fast way of updating your web app. But if you've got an existing web server, you can just reuse it for that. Here's the web app. This is the HTML code. So there's a few things you need to do in your web app. The first thing is you need to include our style sheet. Now, on the display, on the device with a screen, we add a header at the top. There's two reasons for that. One is to brand your action. And secondly, it allows the user to navigate away from your action. Now, that means you can't use that area for your game. And the style sheet gives you information about the rest of the screen that's available for rendering your game state. So that's the first thing. Secondly, you include our library. So this will give you access to the interactive Canvas API. We also have some code here in our example in the main.js file, which we'll take a look at. Now, in your web app, you import and initialize our library. Once you do that, you get access to a special instance variable called Assistant Canvas. That is how you actually call the API. The very first thing you need to do when the web app loads is to call the ready method, and that's how you register these callbacks that you've declared in your JavaScript with the API. And now it's ready to accept events. So here's a super simple example. So we've declared one callback, and we call the assistant canvas.ready method. That's how we invoke the API, and we're passing in a reference to those callbacks. So now, once your web app has done that, and typically you should do this on page load, it's ready to accept events based on fulfillment from your intents. So the callbacks for handling those fulfillment updates, there's a special one called onUpdate. So that you need to declare a function called onUpdate. As a parameter, the JSON payload that we specified in our fulfillment logic is passed in as a parameter, and then you can unpack that. And typically, that could contain some game data and some state information. And then you synchronize your local web app state with the fulfillment state. Here's an example that's been fleshed out. Again, this is the same callback we looked at before. You declare this onUpdate, an onUpdate function, and the parameter is the state we got from fulfillment. Just some very basic logic. Remember, we declared the state variable as a value of welcome in our fulfillment. Here we're just checking in the web app whether that is the state that is passed in, and then do some associated logic. And as other states are coming in, you can just extend your switch statement to add other custom logic for your game. Let's go back to fulfillment. So here's another intent handler. So the user said something else, another intent got matched by Dialogflow. Again, we're using our Node.js client library, and we're declaring an instance of the IMMERSIVE RESPONSE class. Now you note there's no URL, right? We previously invoked the welcome intent. It loaded the web app. It's on the device, waiting for new events. When you pass in this information, it doesn't reload the web app. It just passes the state information. So here we are using the same state variable we had before, but now it has a different value. Within your web app, you just extend that switch statement, and now you can check for the change value and do something appropriate. So now we have ways for passing information initially when you load the page, and then subsequently when other intents are invoked by the user. OK, so now we know how to get data and state information from fulfillment to the web app, but there actually is also a way for the web app to invoke intents. So this is very similar to the user talking to the device. So the user provides voice or keyboard input, right? Then it invokes an intent. But now we have an API to do the same thing. You can do this programmatically. And the API is called send text query. Again, you use our assistant canvas instance to call that API. So this is very useful in your custom GUI for handling buttons, or even doing asynchronous intent invocations, which wasn't possible up until now. OK, here's a super simple example. At the top is the HTML. We're declaring a button, and we're just saying there's a JavaScript function that gets called when the user clicks on the button. And then in our function, we're simply calling the send text query method of our Assistant Canvas API. And we pass in a phrase. So again, it's like the user said this, but you're doing this programmatically. That gets passed on to Dialogflow. Dialogflow, that's the same as it does with the user input, matches an intent, and invokes the fulfillment. Another very useful feature that is provided as part of the interactive Canvas experience is the ability to sync audio with your game animation. And a lot of our games that we're showcasing is using that. So what you do is you render TTS like you normally do in a conversational action. For example, you might provide a simple response in your fulfillment. But now we have a special callback that gets invoked that tracks the completion of each part of that TTS. And at each time that callback is called, you can now synchronize some game animation or game state with each of those invocations. How does this work? Well, we're relying on SSML. So SSML is something we've supported from the beginning with Actions. It's a super powerful feature for developers to basically control the way the TTS gets pronounced. So developers can change the pronunciation of individual words or sentences. You can add sound effects. You can even add background music. And in particular, on our platform, we actually allow you to layer TTS and various sounds, which is unique to our platform. There's a standard mark tag in SSML, and we're using that for this feature. So that allows you to place markers in the TTS that you're providing for your response. And events are generated for each of those when the TTS is played back. The platform also automatically gives you start and end events for your TTS. Here's a super simple example. This is the SSML. Here we have got two marks. The one is called here, and the other one's called there. Here's our callback. Now, previously we looked at the onUpdate. Now we're looking at another one called onTTS mark. Works in a similar way, but now the parameter is the name of the mark. So as the TTS is played back, it hits each of those marks. That name is passed into this callback, and then your code can do the appropriate thing. So here we're just checking for here and there, and we can synchronize our game animation based on those events. So let's do a quick recap on the life cycle. The user talks to the device. That user input gets passed on to Dialogflow. Dialogflow matches an intent, which then invokes fulfillment, the code that provides a dynamic response. It now provides a new kind of response, an immersive response, which gives a URL to the device. The device loads the associated web app. When the web app loads, it initializes our interactive canvas API and registers some callbacks. Now the web app is ready to accept events from fulfillment. The web app is also capable of invoking intents on the platform. So if you've done a conversational action before, it's very similar. We're reusing almost all of that existing lifecycle. Now we just have a web app as a way of providing a different view on your action. There are some technical considerations. As I mentioned, we add a header, and on mobile devices, it's 56 dp high. On Google Nest Hub, it's 96 dp, and on other smart displays, it's 120 dp high. So don't put any content or interactive elements behind that area on the screen. Also, on mobile devices, when the user provides voice input, there's like a transient transcript that the assistant provides of what the user is saying. So don't put any critical information towards the bottom of the screen. From a technical point of view, start with a responsive design. So that'll help you to automatically handle different screen sizes, from small phones to smart displays, which come in different resolutions. You can use your favorite responsive framework or library, or you can just use CSS media queries. Also decide whether your game is going to support both landscape and portrait. Users should be able to use the mic or the keyboard to complete any critical conversational actions. You can provide access to any non-critical interactions via touch only if you want. Consider using the HTML media element to provide sound playing locally within the web app. That's very useful for like sound effects or background music. It really elevates the production value of your game. Also, very importantly, keep your game logic in fulfillment. If you are supporting voice only, start with that first. Then reuse the logic to drive updates to the interactive version of the action. So think of interactive canvas as another view on your action. There are some limitations. So when we load the web app, it actually loads like a web page within incognito mode within Chrome. So that means no local storage within the web app. However, you can use our existing APIs in fulfillment to store session data. No pop-ups are allowed, no modal dialogues. Also, the origin is set to null. That will have an impact on things like AJAX calls and requests for static media. So you might have to configure your web server to support that. Also be aware that devices that run the interactive experience might have limited hardware capabilities. So this goes for both smart displays and older mobile phones. Don't expect the kind of performance you would get on a desktop browser. We've open sourced a very simple sample that you can go and try on GitHub. It's a very simple animation. It's got a little shape and that keeps turning. And then the user can use voice commands to basically interact with this animation. The user could say, change it to red or change it to blue, and then it will actually do that. Or the user can say, stop animating or start animating, and then you can control that. Very simple, but it shows you the basic life cycle of a typical conversational action. So voice commands are implemented in Dialogflow. We do intent matching. Let's take a look at the code, the fulfillment, and the web logic behind that. So here in our fulfillment logic, we have got an intent handler for the welcome intent. Note we're using immersive response. We're providing the URL to the HTTPS endpoint for our web app. So that you should be familiar with. Here we have another intent. This is the intent that gets matched when the user changes the color. And all we're doing now is we're using immersive response. We don't need to provide a URL. We're going to keep that web app running. We provide state information, which is just the color that the user selected. Here are another 2 to 10 intents, and this is for controlling the animation. Here we provide a spin value, which is just the state of the animation. Here's the web app part of it. You have to include our library. And we're going to use the Pixie JavaScript library, which is a very popular framework for doing JavaScript animation. We also have some code in main.js, and we're going to look at that. So to start with, we just initialize Pixie, and we get a renderer that actually draws the graphics. There's also some other variables for the display and the game state. Here's our main callback, and we're implementing the onUpdate function callback. And we're just checking for 2 things. We look at the JSON data that's passed in, we get the color value, and we get the spin value, and then we synchronize local variables. And this is a typical pattern where data from performance is synchronized with variables within your game. This one is interesting in that you can also touch the screen. So as you touch the screen, it toggles the variable that controls the animation. So again, we're just flipping the value of the spin variable in the game state. Here's our main animation frame. It's the function that it calls for generating each frame in the animation. It does a little bit of math and figures out how to rotate the shape. And then, of course, it uses the values of the color and the spin, whether it should be animating or not. And that's pretty much all the code that's in our sample. So go and give it a try on GitHub. OK, so as a developer, how do you debug your interactive canvas action? Well, our simulator supports this, so you can run it just like you normally do a conversational action. But in particular, you can use the Chrome Dev tools to look at the iframe that we use to host that web app. So you can use all the existing tools for logging, for debugging, for looking at the DOM structure. It's all a very powerful tool for debugging. You can also test it on any device with the same developer account. And in our sample, we provide a debug overlay, which just provides the console output. So it's useful for looking at the output on a display. We also use an open source library for the statistics. And this is useful for tracking how well our performance is going on different devices. What is the frame rate, for example? And that's all it takes to create an interactive canvas action.
Well, I hope you're all excited to get started. Before we get off to the races, though, I want to talk through some design principles and some best practices that will help maximize the impact of your content. Let me get a quick show of hands. How many of you have created a voice game for Google Assistant? OK, a few of you in the room, and I'm sure there's several that are following along online as well. For you, there's a lot of ways to enhance your voice games by leveraging the visual capabilities of the platform. As Leon mentioned, the backbone of a canvas action is a conversational action. And so adding visuals is actually a very straightforward process. In the act of building your voice game, you've probably thought a lot about where the payoffs and experiences that you really want to reward the player are. Using SSML, it's extremely easy to align your animations with your voices and sounds that maximize this impact for your users. Another thing when you've been building voice games that you might have run into is some complexity where something that might be very difficult to describe or done through lengthy conversation. For example, whose turn it is, or lengthy clues about visuals. Keep in mind that these moments might be easily solved using visuals and leverage that capability in order to enhance your game. Oftentimes, people are nervous that maybe this will create a situation where their voice action won't work as well, but because you can determine what the capabilities of the surface you're on is, you can actually create different conversations depending on what surface your user is playing on. Now, for those of you who haven't created a voice game, we're excited for you to start developing games that are bespoke for the visual display device. Games historically that have been successful on the platform have really leveraged the new, unique capabilities of the platform. What we believe is the unique advantage of Canvas and the Google Assistant is that it enables a new interaction model that just isn't possible on other platforms. For voice games, we've already been able to use Google's speech recognition and natural language understanding to process complex voice inputs, but the output has strictly been audio. For traditional games, you've had access to the visual surface, but you haven't had access to the more sophisticated language understanding that Google Assistant provides. Interactive Canvas, along with Google Assistant, provides you this new way to interact and create content. One of the key important things to keep in mind is that the experiences that are going to succeed in this space are focused on voice being the right input for your experience. If you simply map verbal commands to a controller input and the user is saying up, go right, shoot, you're probably not taking advantage of what the capabilities of the platform fully allows. If you've built voice games and you've spent a lot of time creating an immersive world through text only, make sure that you're taking a step back and realizing that there are mechanics that you can use with the visual display that will create a transformative experience for the player as well. While on the technical side, we can just simply port HTML5 games, we're encouraged and interested in seeing you create games that really leverage the voice component of the platform. Let's take a look at a couple of examples that really leverage this. One thing that we've been thinking about is word games. I think there's a lot that affords word games to be on the platform because of the fact that visual puzzles are a way, the visual capabilities showcase a lot of ways that you can engage with word puzzles. Crossword puzzles, anagrams like what we're showing on the right hand there, even image puzzles where you're given images and have to determine what the clue are well designed for the visual surface. In addition, because they're word games and the inputs are actually words, it actually affords the user to speak those answers with their voice. A slightly more complex example is an adventure game. Text-based adventures were super popular back in the day and created an immersive world when the only input a user had was through text. We have an opportunity today to restructure how adventure games work. We don't have to have text-based input where you're issuing commands to your character. Rather, let's create experiences where characters in the game are helping you navigate the experience through conversation, not through direct actions. So in this example on the right that you see, we've created a world, and this is just a simple example, where characters are helping you guide the conversation. You're not in a situation where you're like, talk to character on the left. The character is already initiating the conversation with you. And astute users will notice that the response to where we are is based on the context clue on the top right, where Big Ben is in the background, and they'll recognize that the answer is London. Another unique platform advantage, specifically to our smart displays, is that they often reside in common areas. Because of this, having games that really focus on social interaction is something that's unique to this platform. And as well, being in the home, you have access to a very unique social graph, that of your family and your home. One way to engage with this is through trivia games, as Lucky Trivia has done, but there are other types of examples where you're really playing on the fact that being in the same environment allows social interactions to flourish. Additionally, rather than having to set up multiple types of inputs or making sure things are connected, everyone can use what they've already have for input, their voice. Persistent games have been popular in mobile and really showcase the progress of RPGs as well as farming games. These types of environments where users are making continuous progress have been very popular there, but have relied primarily on multiplayer online interactions to showcase the progress. We have an opportunity here where, by focusing on the local, we can create collaborative experiences where players within the same household are able to contribute to the same persistent state. In addition, we have access to a local graph, not simply through Google's APIs, but as well as through the fact that you're co-located in the same area and can collaborate together. At the end of the day, we're interested in seeing what you have. These are not meant to be prescriptive. They're simply ideas to help the creative juices start. We're really looking forward to see what you create. So before we wrap up, I wanted to spend a couple more minutes talking about some best practices that we found in working with Interactive Canvas. First, as more assistant display devices start to arise in the market, it's tempting to create a one-size-fits-all design that actually targets all the surfaces. While creating responsive designs will enable Canvas to deploy your action to all of these surfaces, it's important to also keep in mind that usage patterns for these surfaces are actually very unique. Smart displays afford multiple users or in common areas so that multiple people can engage with them. And phones are better suited for personal, quick interactions that might take action throughout the course of the day. Consider how your players are going to engage with your game even outside of your game. really focus on voice-forward interactions. Conversations are much more helpful and create a deeper sense of immersion for your player base. And if you only use your voice as a controller, there's a sense of breakage in terms of what the players are actively engaging with. Where possible, set up situations where you can interact with characters rather than issue direct commands to your character. For traditional game developers, it's an important challenge to realize that the scope of what voice commands entails is actually quite large. And so we need to definitely leverage our visual capabilities to showcase what the users can interact with. If you're coming from the world where you've created voice games, you've already engaged in this creative process to come up with the right text, but take advantage of the visuals to potentially simplify those interactions. Despite our best efforts, users can still potentially get lost, or in a social setting, there might be some crosstalk that issues incorrect commands to the platform. In these types of situations, make sure that you're handling the errors as well, and potentially provide explicit audio suggestions for the user so that they can get back on track in your game. Optimizing your display is important. With a visual display that is ripe for visual payoff, make sure that you use SSML and other tools to really maximize the payoff and synchronize your audio with your video animations. Again, understand that these devices can be viewed at multiple viewing angles and distances, so make sure that your text is sized correctly. Once you've created your game, figuring out how you get discovered is vitally important as well. As Leon mentioned before, setting up built-in intents allow you to be cataloged when the user says, "Hey G, play a game." In addition to this, focus on making sure that your games are high quality, have high retention and engagement, and leverage some of the new technologies that we bring. And finally, we're excited to announce Interactive Canvas for Developer Preview, but your feedback is vital to us for improving and continuously improving the platform. We'll help and continue to develop new tools for you, but your feedback in terms of finding bugs and submitting them in our public bug tracker is important, but also features that you would like to see and would like access to over the course of your development. We have a couple more recommended I/O sessions that cover Interactive Canvas. Voice and Visuals talks about how you can create multimodal experiences that span the smart speakers as well as display devices. And how we built our sandbox demos will showcase how we created Jungle Dream and how you can create a similar experience as well. Times are listed on here, but if you happen to miss them or aren't available, they're going to be available as videos on YouTube. And that's it. Primarily, we want you to hit g.co/interactivecanvas to get started. That will give you access to the APIs and to the documentation. Leon talked us through some code samples. They're available on GitHub. Make sure you talk to us on social media, Twitter and Reddit, and we'd love your feedback on our public bug tracker. Thank you for coming today. We can't wait to see what you'll create.